Well, good afternoon, everyone. Today we're going to be doing a overview of 454B refrigerant, and we're going to be going out here on the YouTube training channel. So a little bit later on, if you go out to the YouTube training channel, you'll be able to find this under 454B overview, refrigerant overview, and today's date code will be 0408-2024. So team, what I'm going to do at this time, I'm going to go ahead and shut my camera off because it seems to stream a little bit better when we do that. And on our video today, we've got Christian McGinty as well as Jessica Petruccio. And so they're going to be joining us to generate this video today. Say hi, everybody.
Hello.
Hello.
There you go. And I'm going to go ahead and just kill my camera because it does seem to stream a little bit better. And if you guys will please help me, kind of keep track of the information on here. Sometimes when I'm doing the video itself, I'm unable to really be my own scribe, so to speak. So if you see something that doesn't look right, please say something as we go through our training video today. In addition, if you would please, Jessica and Christian, please ask those good questions, because the participants, or those that will be viewing this video, are going to want to know some of those really good questions that you have on your mind. So please ask those questions as we go through and do this video together today.
Will do.
All right. So with that said, let's go ahead and pull up our little training video today. So can you guys see the screen okay today?
Looks good.
All right. So again, everyone, today is going to be a 454B refrigerant information overview. And so let's go ahead and just jump right on into it. Get my little clicker going here. See if that's going to work all right. There we go. So everyone should be able to see that very first screen. So today, let's remember something. The 454B refrigerant is also known as an XL41. And basically what it is, it's going to be an HFO type of refrigerant. Now, this is the refrigerant that Johnson Controls, and quite frankly, several major manufacturers have decided to utilize for their upcoming refrigerant. Now, this is an A2L refrigerant, generically speaking, but specifically 454B refrigerant has been the refrigerant of choice that we'll be utilizing. As we take a look at the refrigerant, though, I'd kind of like to take a minute or two and just talk a little bit about refrigerant development over the years and why that kind of applies today with the ASHRAE 34 A2L classification. So as we can kind of see from the timeline, back in the 1930s, they started developing CFC refrigerants, which are chlorofluorocarbon refrigerants. And some examples of that would be like R12 and R502 and R500 back in the day for air conditioning application. Later on in the 50s, we got into HCFCs, which would be like R22, which is the replacement for 500 back in the day for air conditioning applications. Now, it did have a lower ozone depleting potential. That's what ODP means, but it still had a very high GWP, which is a global warming potential. We then progressed into the 1990s with what we call HFC refrigerants, which would be like 410A would be an example, which we've had around for quite some time. Now, this particular refrigerant, 410A, it's a 400 series refrigerant. And what that means is that typically a 400 series refrigerant may have some temperature glide, and we'll talk a little bit more about that later. Whereas a 500 series refrigerant would be one that did not have temperature glide, something like 502, for instance, or one of those other different, some of those other 500 series refrigerants. Now, on the HFCs, the 410A refrigerant, as an example, has no ozone depleting potential. However, it still has a very high global warming potential. So as we take a look at these refrigerants, we notice that they are classified by ASHRAE 34 as an A1 classification, which means they have no flame propagation. You know, if you're in the testing facility, which we'll talk about in a little bit, they don't actually progress with, they don't consider them a flammable refrigerant because they don't have any flame propagation in the test facility. Today and tomorrow, looking forward, we have what we call HFO refrigerants, which are olefin, hydrofluoroolefin blends. Some examples would be 454B and 454C and so on. Now, these refrigerants have no ozone depleting potential and very low global warming potential, and they are classified with our ASHRAE 34 classification as mildly flammable. So part of this training today is to kind of give everybody a chance to just relax and realize that this is even though it's a mildly flammable refrigerant, we want to keep in perspective that it's extremely, very mildly flammable. and we'll get into some of those testing procedures and stuff like that here in a little bit. Any
Hey,
questions?
Joel.
Yes, sir.
I got a question for you. Does that mean that they're gonna burn my house down? They're gonna blow up when I put a torch to them?
Man, I'll tell you, that's a great question. And the answer is absolutely not. And so these refrigerants, even though they're classified as mildly flammable refrigerants, you got to remember, in order for them to burn, you have to have a certain condition, if you will. You have to have the perfect amount of oxygen or air in the case of being out in the field, just air, perfect combination of air and an ignition source, a flame source that's constantly going on this before it'll even burn. And that's a great question. So no, you're not going to have your house blowing up. You're not going to have, explosions when you're out here working on it. Now, we are going to talk about some best practices, Christian, specifically on purging the unit and evacuating it and purging it again with an inert gas like nitrogen, just to make sure we don't have anything in the line set if we have to service one of these units. But no, they're very, very safe, but we do want to make sure and follow industry guidelines as far as serviceability. So that was a great question. Good. Any other good questions or comments? Okay, good. So one of the things we like to talk about right at the very beginning is there is no drop-in replacement for 454B. Now, equipment made and to be used with A2L refrigerants in general are going to have some sensors. They're going to have some mitigation logic. They're going to have some special labelings and stuff like that. And so A2L refrigerants are going to be classified as again, a mildly flammable refrigerant. And they're going to have some special devices on them. And again, we want to make sure we understand that the labeling and the sensors and stuff like that will be exclusive to like the A2L type of refrigerants. Now also remember A1 refrigerants like 410A and R22 and some of those refrigerants are not going to be equipped with these devices. So to try to take 454B and put it into like an R22 system is not going to be recommended or allowed to be able to do that. Also, please remember, using an A2L refrigerant in a system that's made for an A1 refrigerant is not allowed and could result in some pretty serious safety issues as far as trying to mix those refrigerants up. In addition, the industry has not addressed or designed any retrofit kits to date anyway to safely mix these groups of refrigerants. So please do not attempt to retrofit or mix these refrigerants in the field. That's a big deal. Christian, what do you have to say about that?
You can't use R454 to top off 410, can you?
No, that's a great question, and that would be something that a technician might be tempted to do. But this is the best practice that I could say right here at this point. When in doubt, get it out. So if you've got a leak in the system, get the refrigerant out, repair that leak, and then charge it up with virgin refrigerant or approved recycled refrigerant, regardless if it's 410A or 454B. So that was a great question. Good question.
And that goes for R32 as well, right? You can't use that to top it off?
Absolutely. That is correct. So we don't want to mix any refrigerants, even to your good point, even if they're both A2L refrigerants. For instance, R32 is considered an A2L refrigerant, and so is 454B. But we would not want to mix those refrigerants together. That's a great question.
Joel, I have a question. You say that there are no drop-in replacements. So, with R22, we had 407C, or I think it was MO99. Is there going to be one for R410A for us to use?
There is not. So that's a good question. So the 410A refrigerant, unlike some of our other refrigerants, 410A refrigerants being a 400 series refrigerant, is not designed to have a retrofit or a drop-in replacement. And so the same thing especially goes for 454B. To Christian's previous question, we wouldn't want to take 454B and try to top off a 410A unit, or we wouldn't want to take 410A and try to top off a 454B unit. Good question. Good comments.
So the best rule of thumb is single refrigerant in a circuit, no mixing period.
That's the best practice. Exactly, Christian. Don't mix refrigerant, single refrigerant in the unit. And like I say, and I've said this for years, especially with the temperature, if you've got a temperature glide on that refrigerant like 454B has, and we'll talk a little bit more about that later, if you're in doubt as far as the percentage of refrigerant in the system, when in doubt, get it out, get a good evacuation, and recharge with fresh refrigerant is what we recommend.
Great. Got it. Thank you.
Yes, sir. Good question. Okay. So the next thing we're going to talk a little bit about is adoption of codes. And I'm not going to spend a huge amount of time on this, but as everyone can see, the code adoption has been completed in a lot of our states. We see that in the purple area, in the purple areas like Nevada and Kentucky, there are some special regulatory processes. And again, just check with your local utilities, your local authorities and stuff like that for your specific, codes or what have you in your particular jurisdiction. So you can kind of see from the map there that almost everyone is completed. Alaska and Wisconsin and Virginia are a few that are still in the process of code adoption, but for the most part, we're pretty well squared away across the country. Now, some design requirements that we'd like to talk a little bit about. Air conditioning system requirements specifically for A2L refrigerants fall under a UL. I'm not going to read all that, but basically UL rating and so on, 4th edition. Some of the design requirements that we will talk about, though, are going to be really centered around prevention of safety issues. And one of those, starting out, is labeling. We want to make sure that when we have a 454B system, and they're going to have the appropriate labels on there. And some of those labels are going to be along the lines of, mildly flammable refrigerant, or this is an A2L refrigerant, which is classified by ASHRAE 34 as a mildly flammable refrigerant, and so on. So labeling is going to be an important factor. In addition, leak prevention, and this is something that we've dealt with, all of our careers basically in refrigeration as well as air conditioning, HVAC environment, is, we want to have really good leak prevention. And that means, properly brazed joints or properly swedged joints and so on. We want to make sure that we pressurize the system. We want to make sure we evacuate accordingly. We want to make sure things are charged up properly. But leak prevention is something that we've all been dealing with for years and years. And we want to continue those good practices to make sure that we don't have leaks. And if we do have leaks, get them identified and get them repaired. In addition, preventing flammable concentrations from forming by utilizing ventilation and dilution of our refrigerant concentrations. Now, this is a big deal, especially with A2L refrigerants. Now, for years and years in mechanical rooms, you'll notice mechanical rooms in industrial environments, they've got ventilation fans in there because the reason being is refrigerants, all refrigerants that we utilize in HVAC currently anyway, are going to be heavier than air. So that refrigerant, as it starts to concentrate and starts settling down into a mechanical room, ventilation and dilution has always been the best procedures and the best practice to make sure we don't have refrigerants, settling down into low areas of a mechanical room and asphyxiating somebody that goes in there. So we're just going to continue with that ventilation and dilution practice with A2L refrigerants because we also want to prevent flammable concentrations. Now remember, team, every flammable substance on planet Earth, it doesn't matter if it's a fuel refrigerant, it doesn't matter if it's a gaseous refrigerant, it doesn't matter what it is. Flammable concentrations can be prevented by understanding that there's always going to be an upper and a lower flammability or ignition point. So basically, if there's too much air, it won't burn. If there's not enough air, it won't burn. So please remember that by preventing these flammable concentrations from forming in the first place by good ventilation and good dilution of those refrigerant concentrations whenever we work on refrigerant. To give an example, if I'm working on an A2L refrigerant, for instance, 454B, and I suspect there's a leak in a closet, we'll say, inside the evaporator, inside the home. Well, what I'm going to do is I'm going to take off the service panels and I'm going to get a fan. I'm going to take the fan, my service fan, out of my truck, and I'm going to make sure I've got lots of air just circulating and moving all around in that entire area to make sure that I reduce that flammable concentration or that potential flammable concentration by just a lot of ventilation. So we just want to keep that in perspective. We want to make sure that we ventilate and dilute any refrigerant concentrations if we suspect a leak. In addition, we want to prevent ignition sources or by what I mean by that, tools and safe practices. We don't want to have tools that are going to be sparking and arcing. As a matter of fact, we're going to talk a little bit later on about a capacitor discharge tool. It's a special tool that you're going to put across the capacitor instead of just your screwdriver. And as everyone knows, if you've done any service work, when you go to short a capacitor out for safety, which is good practice, you want to make sure that's not holding a charge. But if you use a screwdriver, sometimes you can draw an arc. So we want to not utilize a screwdriver moving forward if we're dealing with a A2L type of refrigerant, because we don't want to have an ignition source. And then finally, service training and literature, just like we're doing today. We're doing some training, and we want to make sure that everyone is up to speed with service training, as well as any pertinent literature concerning 454B/A2L refrigerants in general. Any questions or comments on some of these highlights as we move forward with design requirements and considerations?
Joel, is R454 being a 400 series refrigerant using the same oil as 410?
You know what? That's an excellent question, and the answer is yes, it is. So being a 400 series refrigerant and being what we call an HFO, we talked about that a little earlier, it does use polyol ester oil. Polyol ester oil is the same refrigerant we've been utilizing in 410A systems for years. That's a good question.
Okay, so when it comes, because the industry is going toward pressing a lot of refrigerant circuitry, so we need to make sure that we go back to our manufacturers and just make sure that R454 is approved for the O-rings for the press. But I don't foresee any issues with that, just as long as the manufacturer approves it for the oil compatibility with these press fittings. Yeah.
That's an excellent point, Christian. And the answer is I concur and agree 100%. So basically, if you've got press fittings now, the ProPress type of fittings or the non-braze type of fittings that your customers are currently utilizing or utilizing right now, if they're approved for 410A, they're going to be approved. They should be approved for 454B because it uses the same oil, the polyol ester oil, and actually the pressures on 454B are very similar to 410A as far as suction pressure and head pressure and stuff like that. So, as long as the seals and whatnot are good for the current 410A oil, it should be fine for 454B as well. Good comment. That's a great point. Okay. So let's dig in a little bit more about this ASHRAE 34 classification specifically. So A2L refrigerants, which include 454B, they have a low toxicity and are mildly flammable. They're considered mildly flammable. So as you kind of take a look at this chart over, it's pretty colorful on the right-hand side there. You can see that as flammability increases, we start going up the scale. To give an example, an A3 refrigerant is fairly non-toxic, but it's got higher flammability. A B3 refrigerant would be flammable and toxic as well. So that might be like B3. I think ammonia, for instance, is classified as a B3. You get into like your A2 and your B2, you'll see those are flammable and so on. And you can tell the A2L is kind of a classification in itself that it has lower flammability. They don't consider it completely non-flammable, but it is lower flammability and lower toxicity. And even though it's mildly flammable, we still have lower toxicity. The other thing is they also have a lower GWP than commonly used HFC refrigerants. So to give an example, as you take a look at like R22, for instance, that's got a pretty high global warming potential as well as 410A. Some of the other things about A2 or A3 refrigerants, they do have lower flammability. And if you take a look at it closely, you take a look at that scale, the A refrigerants also have lower toxicity. And then finally, as you kind of look at that little scale down below, one of the things that we all have to kind of keep in perspective, that as we lower GWP, global warming potential, the flammability of those refrigerants and substances go up. And so that's kind of where we're at right now as far as that ASHRAE 34 classification, that we just have to live with mildly flammable, and if we want that lower global warming potential. Any questions on that? Okay, good. Okay, so let's talk a little bit about the flammability testing. And so as you take a look, there's different classifications. As you take a look at like class 1, That would be like a 410A or an R22. When they take, what they do is they literally take a 12-liter glass flask in the laboratory, and they've got a stirring mechanism where they can stir up the components in there. They bring air in one side, and they bring metered refrigerant in. When I say metered, a certain amount of refrigerant and air mixture inside this test flask. And then they've got these electrodes that actually spark an arc that will, set it off, or that will ignite these substances they're testing. Now, class 1, as you can see, there's kind of a V there. That V is actually a 90-degree window, or a projected 90-degree window. And let me go ahead and zip this up a little bit so you can kind of see what we're talking about. That apparent 90-degree V is kind of the reference point. And so as you take a look at the photos, the class 1 refrigerant, even though it's a class 1 refrigerant and it's considered non-flammable or low flammability, you can see that even a class 1 refrigerant will burn under certain conditions. And this is something we all need to keep in perspective. R22 will burn all day long under certain conditions, but it's a class 1 refrigerant. 410A will burn all day long. As you kind of look at that class 1 classification up there, you'll see there's a flame there. Well, that's a class 1 refrigerant. Even though it's considered non-flammable, under certain conditions, it will still burn. Now, the class 2L refrigerant, which is what we're talking about with 454B, if you take a look at that V there, you can see very, very clearly in the test procedure there that the class 2L is extremely low flammability. Now, it's mildly flammable. It's classified as mildly flammable, but as you take a look at it, you can see it just barely comes out of the edge of that window or that V for the testing process. So this is great news, and it's a good reason to take a nice big sigh of relief right now. Class 2 refrigerants, Class 2L refrigerants, yes, they're mildly flammable. We're going to follow the rules. We're going to be good stewards. We're going to be careful and all that, but it's not going to blow up, Christian. You're not going to have something that's going to be exploding in your closet when you get a leak or something like that. So that's something we really like to point out to everybody. And then finally, Class 3, that bottom screen down there, that's an example of like propane or natural gas that you're looking at. And so under those conditions of oxygen or air and whatnot, that class 3, it's really got a huge amount of flammability, and that's considered a class 3. So as we take a look at that flame spread up there, some of those text fields up there, the flame spread is greater than 90 degrees. It indicates some degree of flammability. If the spread is beyond 90 degrees, as well as the speed at which it spreads, we define that as a degree of flammability. One more time, 2 being lower flammability, 2 being flammable, or 2L lower flammability, 2L or 2 is flammable, and then 3 is high flammability. So you kind of get an idea that yes, our 454B is mildly flammable, but as you take a look at it, if it would have been just a little tiny bit less, it'd have been classified as a class 1. Any questions or comments on that before we continue?
I just wanted to question, so R454B operates very similarly to 410A then, right? I mean, you look at that, there's not really much of a difference.
That is correct. And Jessica, that's a great observation that, from a flammability testing, but also from a practical field standpoint, if a technician is used to working on 410A systems, he's looking at, a particular suction pressure and a particular high side pressure when he's out there doing service work, it's going to be very, very similar. And even though we're going to have, make sure we've got the proper tools and all that stuff, he's going to be very, very comfortable, or they're going to be very comfortable if they're working on 410A systems now, because it's just no big deal to jump into 454B from a serviceability standpoint. So that's a good observation. Good question and comment.
The reason I bring that up is I know that everybody was a little concerned about the difference going from R410A to a slightly flammable refrigerant, and
yep.
All the building codes had to be changed, and there was a lot of scary theories out there. So thank you for clarifying that, Joel.
Absolutely. Okay, let's talk a little bit about that refrigerant leak detection system. So part of the requirement, what we call mitigation and safety, is leak detection. So as you take a look at some pictures over there, they're just kind of graphics on the left-hand side. You see that we have a refrigerant sensor, a refrigerant leak detection system, basically, and a board. So this refrigerant detection system, it's going to be a board that's going to be physically mounted on the air handler or coil. And we're going to bring our thermostat wiring into the top of it there. We're just going to wire it up like we always have. It's no big deal. Our thermostat, instead of going directly to the unit, it's going to come to this board. And, you're going to have yellow and, first stage, Y1, Y2, and W1 and W2. You're just going to wire your thermostat to this board. It's no big deal. Then there's going to be a harness from the board going down to the equipment. And so that's the key thing. So basically this refrigerant leak detection system is just going to be wired in between the thermostat and the indoor unit. And it's just going to sense if it has a sensor on it. So if it senses a leak in the evaporator or on the indoor unit, if it's an air handler, what it's going to do is going to bring the fan on to make sure we got plenty of ventilation like we talked about, keep that fan moving, and it's going to shut the outdoor unit off so we don't have the unit operating. Now, one of the things, depending on the manufacturer, one of the things that some of the boards will do, depending on manufacturer, they'll lock the unit out after 3 or 4 or 5 tries. On our products, we're not going to lock the unit out, but we are going to shut the outdoor unit off, and we're going to continue to run the fan as long as there's a leak detection threshold. At this time, I don't know what that exact threshold is, but that'll be something later on that we will refine in our training programs as we start doing more intense training as far as air conditioning diagnostics, heat pump diagnostics, and so on. As a matter of fact, one of our participants today, Christian McGinty, Christian, tell us a little bit about some of your upcoming training that you're going to be doing on 454B air conditioning diagnostics.
Sure thing. So actually tomorrow morning, we're having a 4-hour class on AC diagnostics, and we've incorporated R454 into that program. So we are hosting about 25 technicians here. We're going to be going over R22, R410, and R454, the refrigeration cycle, and going to be using some new tools that we have for the A2L program, as well as the National PT Chart app. I want to be able to make sure all the technicians know how to go and find proper saturation temps and pressures for all of the refrigerants that they're going to be exposed to starting this year.
Well, fantastic. As a matter of fact, towards the end of our program today, Christian, we're going to go ahead and do a little pressure temperature examples, a half a dozen pressure temperature examples, and we're going to ask you to go ahead and utilize that app that you're talking about to help us find those answers when we do a little exercise here shortly. So thank you for that.
You're going to take me to task, huh? All right.
Oh,
you're not just a pretty face today, Christian. We're putting you to work.
I'm not a pretty face any day.
Oh.
Absolutely.
Well, Joel, back to what you said about Johnson Controls RDS and Champion's RDS. So you said that it will not lock out. We have heard some of our competitors that if it goes into the RDS is activated 3 times, the system will lock out. I just want to clarify, ours will not do that, right?
That is correct. That's my understanding at this point. I've talked to some of our engineering folks, and they believe a better engineering approach is to let the unit continue to run. And then if for some reason, if there's enough of a leak to where the outdoor unit actually offsets or actually trips one of our low pressure safety, the outdoor unit won't run anyway as a double safety, kind of backing up the RDS system. So as a double safety, so the homeowner is going to realize that, hey, my house isn't cool when it should be cool, or my heat pump's not heating like it should. And so I'm going to call a technician anyway, and that's going to bring the technician out. But in the meantime, as long as it's still safe to operate the equipment and it hasn't gone out on a low pressure switch, we're going to go ahead and utilize the engineering scheme. Bring the fan on, let's be safe, bring the fan on, and so on, because as we all know, if you've got a very, very slight, very, very small leak in a system, it may not really show itself up with the low pressure switch tripping, for 6 months. I mean, the unit will still work fine. It just isn't working quite as good as it was. So I think our engineering approach is probably a very conservative one. And I like it because we want to be able to make sure that the homeowner's not stuck without any heat or stuck without any cooling if it's 110 degrees outside, if they've only lost maybe an ounce or 2 refrigerant in the system. So we're going to let that unit run. We're going to bring the fan on. We're going to make sure that it continues to be safe. And then if it continues to leak out to a point where the unit's actually compromised as far as reliability or more specifically operation, you know, the homeowner is going to pick up on that quickly and they're going to call a technician and get somebody out there anyway. So that's kind of our approach on it. Good. Yeah.
Joel, now do these sensors come factory installed or are they field installed?
Christian, that's a great question. So every one of our air handlers and coils, current production are going to be, now this may change at some point, but as it stands now, all of our units are going to be shipped with the refrigerant detector system installed, and it's going to have the sensor as part of that installation. Good question.
On all indoor units. So the
Yes.
outdoor units will not have that, but the indoor units will.
That is correct. This is the indoor unit, which will be the evaporator, a coil, like a cased coil, for instance, Jessica, or an air handler. Any of our outdoor units. That is correct. Good question. Excellent. So let's talk a little bit about best practices, team. So some of the things that we've done over the years, you know, even if it was an A1 or an A2L refrigerant, our current A2L refrigerant we're talking about, the 454B, we're going to recover refrigerant into an approved recovery cylinder. And that's we've done that for years anyway. Now, that's something since the Montreal Protocol and the no venting laws went into effect and all that stuff. So everybody's used to recovery equipment. We just have to make sure our recovery equipment is rated for the A2L refrigerant. Now, some of the things that we've always done that have been best practice, you know, we purge the unit out. If we have to recover the refrigerant, we recover it. If we have to make a repair, we purge the unit with inert gas, like nitrogen is a good example. You could use helium or others, but nitrogen is inexpensive and it's available. So purging the unit and then evacuating it and purging it again. Well, like what I like to call PEP. Just remember, everybody, PEP, PEP, purge, evacuate, purge. This has been best practice for, you know, as long as I've been in the industry, over 50 years. That, you know, this is just what we do. When we open a system up, we purge it. We evacuate it, we purge it again. This has always been a best practice, regardless of the refrigerant, especially low temp. Well, now with A2L refrigerants, this is going to be a requirement. We want to make sure that as we open the system up, we get the refrigerant out, we purge any refrigerant that's in there, and we want to make absolutely certain that we get an evacuation and we purge it again. That way we have no chance of any flammable concentrations being in the refrigerant line set or the equipment. Then we're going to go ahead and make our repair. That's always been required anyway. We want to have nitrogen going through the line set. So if we're brazing a line up, that way it keeps it nice and clean and dry. So that's been something that we've been doing for years and years, and we still need to do that, or it's still required with A2L. We're going to pressure test and leak test like we've always done. That's a requirement that doesn't change. And then we're going to evacuate the system to 500 microns or less. Now, that's always been best practice. But now with A2L refrigerants, we really need to do it. That's going to be a requirement because we want to make sure we don't have any leaks. We want to make absolutely certain that we get a good evacuation for best practice. And again, it's always been a best practice with any refrigerant, but now we really want you to do it as a requirement with A2L. And then finally, properly charge the system. Well, that's always been a requirement anyway. So, you know, the best practices that we're talking about have really been around for a long time. But now with A2L refrigerants, because of the mild flammability and all the different things, let's just all make sure and make ourselves and our technicians do this as a requirement with A2L, all the things that we've just discussed. Good. Any questions or comments on that, team? Okay.
Nope. These just seem like things that you've always talked about, Joel.
Absolutely. You know, I've been teaching and preaching this and practicing this myself for over 50 years. I've, you know, especially when you're doing low temp refrigeration, you know, back in the day, you know, when I was doing a lot of commercial refrigeration, you just had to keep it clean. You had to keep it dry. You had to get a super good evacuation and so on. Otherwise, you're going to have systems that just wouldn't perform like they were supposed to. So like I said, these are just best practices, but they've been around a long time, Jessica, to your good point.
So Joel, so say you are repairing a coil or something in a small closet.
Mm-hmm.
What do you recommend? Is that where PEP comes into place? You know, purge, evacuate, and purge again.
Absolutely.
So that there's not refrigerant there. I believe you had mentioned before, you know, remove it. When in doubt, get it out, right?
Absolutely. That's absolutely right. And that's part of that recovery and evacuate scheme is to, get the refrigerant out and then purge the lines really good. You get a good evacuation, then purge it again. And then after you've done that, you can safely open the system up and just get your work done. And then remember, if there is any refrigerant in that closet that may be leaked out and it's in the closet itself, when we open that closet up and when we open up the service panels and stuff on the coil or the air handler, whatever the case may be, we're going to want to make sure that we've got a fan that we're just really blowing a lot of fresh air in there to dilute any fumes that might be in there. Even though it takes a lot to make these refrigerants burn, we want to make sure we never, ever, ever reach a flammable or combustible combination of air and refrigerant. And the best way to do that is to ventilate and to dilute. Ventilation and dilution is the key for safety if you think there's any refrigerant laying in that closet. Good question.
So Joel, a lot of our technicians like to, when there's a repair that needs to be done on the evaporator coil indoors, a lot of our technicians like to do what they call pulling the refrigerant back to the compressor and turning off the service valves and then pulling vacuum on the line set in the indoor unit from there. Would that still be acceptable?
Oh, absolutely. Absolutely. So that pump down sequence that you've just described, Christian, is absolutely fine as well. So if you've got a leak and you want to pump the unit down, then by all means pump it down and purge and evacuate and purge just the line set and the indoor coil. That's perfectly fine to do that. Now the only downside would be because 454B is a what we call a zeotropic refrigerant. It has significant glide. If there's any more than about half or if there's any more than about half or more of the refrigerant, or you think there's more than about half out, I would say take it all out, because you may have messed up the refrigerant blend because that leak is going to boil off refrigerant, the components in that refrigerant at different boiling points. So I mean, if it's a very, very slight leak and most of the system charge is still there, you'd probably be okay just to pump it back and do a pump down and then top it off with some fresh 454B. But if you're in doubt of how much is in there, I mean, if you've leaked out most of it, then go ahead and get all that refrigerant out, because when you go back, you don't want to mess your blend up. Because remember, 454B does have a glide to it. We'll discuss that a little bit more in a little bit. Good. That was an excellent question. So team, some of the things that we also wanted to talk about a little bit are tools for A2L refrigerants. Now, a lot of your installation tools and service tools are very, very similar. As a matter of fact, based on the gauges that you have, you may have, if you have like electronic gauges, for instance, you may well have a set of gauges that already have 454B as part of the refrigerants they'll handle. If you don't, you can certainly change gauges to 454B. Now, remember, the 410A gauges are going to be very, very similar as far as pressures and temperatures on the thing. But the point is, we just want to make sure that we've got gauges that are going to be okay for 454B. As far as your refrigerant recovery cylinder, you want to make sure that it's a left-handed thread and it's going to be for flammable refrigerants. Your vacuum pump, you want to make sure and check with your manufacturer to make sure that it's rated for flammable refrigerants. With and they may have sealed switches, they may have like a DC, a brushless motor in there, or whatever. Just make sure that your vacuum pump is rated for A2L refrigerants. Same way with your recovery machines, your gas detectors, and your electronic leak detectors. Make sure that they are compatible for and that they will detect, for instance, your A2L, your 2L compatible refrigerants. As far as your scales and stuff, there's no change here. A scale's a scale. It's no big deal. A ventilation fan, again, ventilation fans are going to be ventilation fans. You just want to make sure that you have the ability to ventilate that mechanical room. If you open up a cabinet and stuff, make sure you get plenty of fresh air in there. And then hand tools, electrical hand tools, preferably your AHRI 80-17 rated non-sparking hand tools. And so that means, your dikes and your wire cutters and stuff, most of them are insulated anyway. They're non-sparking anyway, but just make sure that, you're always aware of any kind of ignition source or spark hazard. And then chemical compatible fire extinguishers. If you've got a dry chemical fire extinguishers like A, B, and C rated, you know, for oils and gas and paper and all that stuff, that's going to be fine for 454B, you know, to have on your truck. So again, you probably have a fire extinguisher on your truck, and it's probably ABC rated anyway. Now back to hand tools. We're going to be talking a little bit about a particular tool. It's called a capacitor discharge tool here in a little bit. So that is one I kind of feature today that I'd like to talk a little bit about when we get to that exact point. So again, here's some pictures of some vacuum pumps, recovery machines, and so on. And again, just make sure that you check with the manufacturer to confirm that those tools, whatever tools you're utilizing, are compatible with A2L refrigerants. Now, as it turns out, here's those capacitor discharge tools that I was talking about. Now, these are just a couple of examples. I think one's a Supco and one's a, I'm not sure of the brand, but I saw it on Amazon. And what these are, they're capacitor discharge tools. You basically shut the power off. If you're going to take the capacitor off your compressor, for instance, out in the outlet, this is on the outdoor unit now. You shut the power off like you always do, and meter the power to make sure that power is off. This is what we always recommend. And then before you handle any capacitors, to make sure, you know, you're going to ventilate outside, make sure there's no leaks outside, or make sure you don't have any concentrations. And then we're going to recommend to consider getting a capacitor discharge tool, because the one place that you're going to have a spark that's going to be drawn with a spark, if you take a screwdriver and put it on a capacitor. And so you always pull a little spark on there. Well, the capacitor discharge tool is designed to discharge that capacitor without generating a spark. So, you know, it's a tool to maybe consider to have on your truck or to have on hand when you're dealing with any A2L refrigerant. Any questions or comments about the tools that we may be looking at purchasing or upgrading to for our 454B refrigerants? Everybody good?
Does this mean all my technicians have to buy new tools?
They probably don't have to buy new tools. It could well be, Christian, that some of the tools they already have are going to be compatible with A2L refrigerants. And if they are, then, you know, no big deal. Just let her rip. They can use those tools they've been using all along. But some of the specialized tools, like the capacitor discharge tools, I would recommend they definitely get one of those, and then double check their vacuum pumps and stuff like that are going to be compatible for A2L refrigerants. But as far as gauges and hoses and stuff like that, I mean, those are all universal. Just make sure that, you know, if they do use for instance, say they have a set of generic suction and discharge pressure gauges, and they're just no refrigerant. I've got a pair in my shed out here that doesn't have any refrigerant on it. It's just a suction gauge and a high side gauge and set of hoses and a manifold set. Works perfectly fine. They're not going to have to change anything with that. But if they want to have specific gauges for the 454B that actually have the pressure temperature chart on the gauge itself, then they're going to have to upgrade that. But as far as the manifold set, it doesn't matter. It's the hoses are the same, the valves are the same, the gauges, no big deal. A gauge is a gauge. So no, they're not going to have to all of a sudden invest in a new set of gauges and all that kind of stuff. Just make sure that your vacuum pumps and any kind of motor or anything like that is compatible. And then these capacitor discharge tools would be a handy tool to have in your pouch, because you're going to be having to short capacitors out. And I think that even with a mildly flammable refrigerant, that'd be a good tool to have in your pouch. Good question. Any other good questions or comments?
Nope.
Okay, Tame. Well, at this time now, for the participants that are watching this video, you can take a minute or two. And you can download this app, and it's a pressure temperature chart app. And so go to your app store for your particular phone or device and search National PT Calculator. And then it's going to give you all kinds of options. You'll be able to select 454B as a favorite if you want to. You can also look at R22 and all these other refrigerants out there. But this is a great app. It's free. We're going to recommend that whoever's watching this video go on out there, maybe pause it for a minute or two and download that app so that you can follow along. We're going to have a little exercise here in another couple minutes, but you can take a minute right now and pause the video and just download this app. Now, once you've downloaded the app, it's going to look like this. Here's a screenshot of the app. It's, again, a free app. National PT Calculator is what we recommend. It works very, very well, and you'll notice it in some of your preferences. You'll be able to go in and select different refrigerants. It's got 410A, it's got R22, it's got 454B, it's got about 15 or 20 different refrigerants in there. And so they're all the refrigerants that we're going to be talking about in our training today will be in there, including 454B. So with all that said, if you've downloaded that app and you'd like to follow along with some exercises, Christian, if you'd go ahead and open up your app, please. Let's do a couple examples for our participants on the video. And what this is, we're going to just review some pressure temperature relationships of 454B refrigerant. Now, please notice that the pressure and temperature relationship is not linear between the liquid and the vapor states like you'd have with some refrigerants like R22. This condition is also known as a glide. So what we're trying to say is that we want to make sure that when we're looking at our app, we want to make sure that if we're looking at a suction pressure, that we look at the vapor saturation temperature. And if we're looking at our high side pressure, we want to make sure we look at the liquid saturation temperature. Now, this is going to become very, very important when we go to calculate our saturation temperature, because later on, or more specifically in our future training programs we're going to be doing with everyone that'll be participating, we're going to be looking at superheat, and we're going to be looking at subcooling. And so if we're looking to calculate superheat, we want to make sure that we look at the vapor saturation temperature for superheat. If we're going to be looking at subcooling calculations on the liquid side, we want to make sure we're looking at the liquid saturation temperature. So when you open up your app, you're going to notice on 454B, there's going to be two saturation temperatures. One's going to say vapor and one's going to say liquid. So we want to make sure we're looking at the proper saturation temperature when we're doing superheat and subcooling. And so let's do some practice together right now. So Christian, if you would please, at 65 pounds of pressure, vapor saturation temperature, tell me, what is the saturation temperature, pressure temperature conversion for 65 pounds vapor on 454B?
I come up with 17.1 on the vapor side.
Okay, well, I've got 17 degrees. That's close enough. Now, technicians, if you're watching this video, please remember, if you're within a half a degree or so, just round up or round down. It's close enough. This is science. It's just not rocket science. It's, a half a degree or 1 degree up or down is going to be plenty close for all field purposes. So let's do another one, Christian. At 135 pounds of vapor pressure, what's the saturation temperature of 135 pounds PSI vapor if we're calculating for subcooling on the suction side?
I'm showing 53 degrees.
Okay, I've got 53 degrees too. That's close enough. Now, if we're going to be doing some subcooling calculations on the high side, it's no big deal. And I want everybody to just kind of take a collective sigh of relief. This is no big deal. We just want to make sure we look at the proper pressures and temperatures. Subcooling is still going to be subcooling with 454B, just like we've always been doing. Superheat's going to be superheat, just like we've always done. It's no big deal. We just want to make sure we're looking at the proper chart when we do our superheat and subcooling calculations. So let's do one on the liquid side, Christian. At 270 pounds of pressure, what's the saturation temperature for R454B at 270 pounds of pressure on the liquid saturation?
Okay, so on the liquid side, I'm coming up with 92.
That's exactly what I got too. Excellent. And let's do another one just for everybody's benefit that's watching the video. At 375, what's the pressure temperature conversion for the liquid saturation temperature if we're doing subcooling calculations on this next example?
That's the vapor. The liquid, it comes up to 116.
16, okay, good. And then finally at 465 on the liquid saturation temperature if we're doing a subcooling calculation on our system.
133.
That's exactly what I got too. So any questions or comments, team, on this? I want everybody just to really wrap their head around. It's just no big deal. It's just another refrigerant. We look at the proper chart. We're still going to do superheat. We're still going to do subcooling. We're going to do all the service practices that we've done all along. It's just no big deal. Any questions or comments on this?
It is interesting to compare the vapor and the liquid and see that glide between the two temperatures. And if you're not careful when you're diagnosing the refrigerant system, that could really maybe throw you off a little bit when you're calculating your subcool and superheat.
And Christian, I couldn't have said that any better. I'll tell you what, that's very, very important. And that's kind of one of the reasons I wanted to make sure and have a little sample of this during our training video today, because it is very important. You know, these were, 454B does have what we call glide. And because of that, there's not going to be the same temperature pressure relationship between the vapor that we use for sub or superheat calculations, or the liquid, which we're going to be using for subcooling calculations. So there is a significant difference. I've noticed as I've taken a look at my app, my 454B app, I've noticed there's 2, 3, maybe sometimes 4 degrees difference in the saturation temperature between the vapor and the liquid. So that's an excellent, excellent point that you've made and a good observation. Good. Good questions, good observations. All right, team, at this time, let's go ahead and talk a little bit about storage of the recovery tanks, and let's talk a little bit about the recovery tanks in general as well. The first thing we're going to notice is for 454B, it's going to be a light gray body with a red band on top. In addition, we're going to notice that on these tanks, on the service tanks, there's going to be a left-handed thread is going to be featured on all of the tanks. Now, this is important. Our service hoses, the service hoses on our gauges are still the normal 1/4-inch right-hand thread service hoses that we've used all along. So the manifold gauges and the manifold itself and our service equipment, it stays the same. However, on the tank itself, on the 454B tank itself, it's going to have left-handed threads. So please remember, we're going to have an adapter to go from the tank to our 1/4-inch service fitting for our hoses. So that's going to be an important thing that, we're going to make sure that all the technicians that are watching this video, make sure that you get some of those left-handed thread adapters for the tank so you can get the refrigerant out of the tanks when you do your 454B servicing. Now, please remember also, this is a good thing to remember also, you want to make sure and position your tank. Look at the tank. There's going to be an arrow on it someplace that'll tell you for liquid or for vapor. Now, we always want to charge 454B in a liquid state, just like we have with 410A for years and years. We want to make sure we charge with a liquid state. And so if that means turning the tank upside down, or if it means keeping the tank upright, just look at the tank. It'll have an arrow on there that'll tell you for liquid. And we want to make sure we charge with liquid, because if we don't, we can mix up the blend. We can mess up the blend if we don't charge with liquid. So it's very, very important that we're going to take liquid from the tank through our manifold set, and then be very, very gently kind of throttle it in to the suction line when we're charging a unit. So let me say it one more time. We're going to take liquid from the tank through our manifold set and use our suction pressure gauge and our suction suction valve on our manifold set to throttle that in. Make sure that we've got that liquid going in a vapor or in a saturated state into the suction line when we charge the units, because we do not want to just slug that liquid in and slug that compressor. So be very, very careful with it. In addition, some manufacturers have a liquid charging tool that allow you to put that on your manifold set to prevent slugging hard liquid into that suction line on the compressor. We don't want to do that for safety, but we still need to charge the units, take liquid from the tank into the suction line of the unit. So we want to be very careful when we do that. Any questions on that or comments on that, Christian? What are your thoughts on that?
It's fairly standard and comparable to 410. The only thing I've seen that we might want to make note of for some of the technicians out there is, even though it's not proper, but I've seen some technicians take a torch and heat up a R410 bottle on cold days to get that refrigerant to move. Now is the time to invest in a tank blanket if you run into those situations, because you don't want an open flame next to this R454 bottle. If your hoses have a leak on it or they're not all the way tight, you're definitely not going to want to have that open flame on the side of that tank.
Man, that is a tremendous service tip. That's a great service tip. And so a warm blanket or a tank blanket or a bucket of hot water is fine. But by all means, do not heat that tank up with a torch. That's a great service tip and a safety tip. Thank you for that. While we're thinking about safety, you're going to notice that on the 454B tank, there's going to be a pressure relief valve that'll reset itself if you pop that off. If you get too much pressure in there, it'll pop it off in a real hot truck. It'll be a pressure relief valve that'll reset itself instead of a rupture disc. We don't have a rupture disc on it to where you just throw or you blow all of that out into a van, for instance. That could be a real safety hazard or flammability hazard. So the 454B, the storage and recovery tanks, will have a pressure relief valve instead of a rupture disc for safety. Okay, let's talk a little bit about transportation real quick. Current DOT regulations allow for the technician to transport up to 440 pounds in his service vehicle. So that's pretty good news. That's quite a bit of refrigerant. So up to 440 pounds in your service truck, up to it. Now, there have been ongoing efforts to reclassify our A2L refrigerants because they are classified as a 2.2 gas instead of a 2.1. This would current regulations right now say that we have to transport these in an upright position. So as it stands right now, we have to transport our 454B tanks in an upright position. And the reason being, if we do pop that rupture disc, we're not blowing a whole bunch of liquid refrigerant into that van, for instance, if it's in a van, from a safety standpoint. However, there are ongoing efforts to reclassify our A2L refrigerants to allow us to go horizontal in our trucks, to transport horizontally. But as it stands right now, as of this video anyway, right now, we are currently not allowed to transport horizontal. They have to be upright in the truck. In addition, some of our National Fire Protection Agency 55 standards have been updated from 10,000 to 80,000 pounds based on zone construction and fire suppression. So from a distributor standpoint, we're able to store a lot more than we were able to currently. And we expect the National Fire Protection Agency to adopt that 55 ruling soon that will allow a higher amount of refrigerant being stored at your warehouse or in your storage facility, as a quick highlight on that. Go ahead and open the floor up for a minute or two. I'm going to go ahead and get out of the PowerPoint, but I'm going to turn my camera back on and we'll get out of our PowerPoint today. And then we're going to, I'll turn my camera back on. We'll entertain any final questions or comments that our panel may have today on our training video. Any final questions or comments for today?
I have a question.
Sure.
Do technicians need to get a new certification for our 454B?
That is a great question, Jessica. As it stands right now, the 608 certification that they currently have, let's say, for instance, they have a universal certification. That's perfectly fine right now. There may be some updated changes coming down the road, but as it stands right now, their current 608 refrigerant certification they have right now is adequate for the time being. Good.
How many, okay, so storage wise or transportation wise, so on a regular local company truck, they can deliver our 454B, correct? I mean, how many pallets or how many cylinders are we talking about? Is there a maximum that they can deliver to a job site? What's kind of the go-to for that?
If you read the rules specifically as they stand right now, 440 pounds would be what they would carry, but that would be unlabeled. Now, Christian, I think we had a discussion about this at one time, and you had the opinion, or you certainly had the input, that as long as they've got the proper labeling on that truck, as far as like their signage and stuff, they can basically haul what they want to haul. But go ahead and clarify that for us, because you're in the distribution world right now.
So all the local companies are going to need to check with their local state's DOT regulations. From what we're understanding is that once you get above that 440, you just have to have placards. And that's mostly for firefighting purposes. If there was an accident, they need to see what placards on your truck. I wouldn't foresee any contractors carrying any more than a skid of R454. So for us as distributors, we're really looking into placarding our trucks because we do ship more than a skid, and 440 pounds is roughly that's about a half a skid. So we're probably going to end up. Let's see here, do some math. Yeah, so 20 jugs is 500 pounds. So that's a half a skid, puts us over. So we're probably going to end up need to get placards on all of our trucks just to make sure that we let the fire department know in the case of an accident what is in the truck.
There you go.
So that's actually good. That's good information for all of your local companies. If you deliver more than half of a skid, you're going to have to get the placards to indicate, I guess, the type of refrigerant that's on there or whatever is necessary to indicate that it's not just R410A. And that could happen often. I mean, how many times you guys sell, a full skid to somebody?
Sure.
They'd have to almost pick it up if you don't have the proper signage.
Well, and the other thing is too, if you think about it, a lot of your welding supply houses, you see these big flatbed trucks going down the highway with, tanks of acetylene and tanks of propane and tanks of, oxygen and all that stuff. And to Christian's good point, they have placards that are appropriate to that substance that they have on the truck. So, current DOT regulations should more than cover any flammable refrigerant or flammable liquid or what have you on your truck, to Christian's good point, as long as you've got the proper placard. Good comments. Good questions.
Joel, from what I've been seeing, a lot of the questions are coming from a lack of knowledge, just a lack of training. And I think it's really important that Wind Supply and the manufacturers get this information out there. Should any of our contractors, technicians, local companies need additional information besides this video, where else can they go? I mean, do we have a website from Champion that can show any information, or is there any information on the Navigator that they can go and find?
Absolutely. We've got lots of stuff out there on our Solution Navigator. As a matter of fact, if you go into the training sites, you'll be able to find, we have some white papers out there. We've also, if they'll go to championhomecomfort.com, championhomecomfort.com, there's some resources out there, some white papers, if you will, that'll actually explain and talk a lot about the 454B refrigerant and the transit, the transition, if you will. So that works very, very well.
Well, and the website championhomecomfort.com I think is beneficial for the homeowners to see as well, because
absolutely,
this is going to be a big change when they hear it's slightly flammable refrigerant going into my house. What does that mean? And that can be scary for everybody. So that information, there's no password back. They can get right to it. Just generic information that talks about it, as well as some videos. So we have the resources available for everybody. Please take the time to review them, because this is coming. And as you guys are aware, we're not going to be manufacturing R410A products for the United States to build as systems starting in January of 2025. So we're already in that transition period now where we're releasing our R454B products. So it is happening.
Absolutely. Well, good. Well, team, thank you so much today for joining our video production. We'll be getting this out on our YouTube training channel. And again, the name of the video will be 454B Overview, and with the date code of 04/08/2024. So
thank you, Christian, for joining us.
Yes, thank you.
Anytime.
Absolutely.
Thanks, Joel.
Thanks, Joel. Thanks, Jeff.
Thanks, everyone. Have a great day today.
You too.
Bye.
Bye.
Bye.